In this tutorial, we are going to talk about static equilibrium. So, what is the basic idea behind static equilibrium? So, when we say something is at equilibrium, meaning the net force is zero, okay? That would mean to say the summation of all the forces in x direction, when you add them, they should give you zero. The summation of all the forces in y direction is zero, so that's the net force is zero. Then also the summation of all the torque should also give you what? Zero. So then when you achieve this, then we conclude that the object is at equilibrium. It is not moving. Okay? The object is at equilibrium, it is not moving. So now I'm going to show you a simple way on how to work around these questions. So let's try to solve this question, which is saying the system in the figure is at equilibrium when m1 is equal to 10 kgs. Find the value of t1, t2 and m2. Assume the pulley to be massless and frictionless so that it does not change the tension in the cord. Okay, and to make things simple, they have given us the answers already. They just want us to find the answers. Okay, so now this type of pulley, what I want you guys to understand is that this T1, it is connected to the same rope as that one. So now, meaning that the weight which I'm going to have here down for M1, I know that for M1 is going to be M1G, that is the weight force. So that tension is the same as T1 there. So I can say that the summation of forces in y direction just for M1 only, okay, is going to be equal to, I have got T1 pointing upward minus M1G pointing downward. So this is going to be zero because we're talking about static equilibrium, something that is at equilibrium. Okay, so this is going to be T1 minus M1G. So if I shift M1G to the other side, it will be M1G being equal to T1. So what is M1? M1 we have been told that is 10. So I'll put 10 here times 9.8 as G being equal to T1. So T1 will be equal to 98 newtons. So the question is find the values of T1, T2 and M1. So now we have T1 and for sure here it is also 1980 newtons. Now for me to find these remaining ones, I have now to start working around the forces in X at the same time the forces in Y. Okay, so one thing we should take note is that T1, if we check at T1, it is like this. So we have 45 here, so that is T1. I can resolve this into components, so it will be T1x and T1y. Okay, that is going to be the same with this other one. So I'll have T2x and T1 or T2y. So this one, it will be the same thing. This is going to be T1x, that's T1y. Now, according to Socator, okay, if I use Socator, sine theta is opposite. Now, in that case, we can clearly see that the opposite, I'll start with T1. So opposite is T1y, hypotenuse is just T1. So to make T1 y as a subunit format, it will be T1 sine theta. So in y we use sine, in x we use cos. Okay, based on Socator. Then what I have to do now is I need to know that I have got the weight force for this guy which is times g. So I'll say the summation of all the forces in x direction. What forces do we have? We have got this force pointing to positive x-axis, that is t1x. I have got t2x pointing toward the negative x-axis, that is t2x. The summation should be replaced by 0 because it is at equilibrium. So t1x is t1 cos theta minus also t2 cos theta. So you can shift t1 to the other side or t2 to the other side. It's basically the same thing. So you have t1 cos theta being equal to t2 cos theta. So now we have t1, and we definitely know t1, right? Let's plug in t1 is 98 because the angle for t1 is 45, being equal to t2. Then the cos for t2, the theta is 53. So to find t2, I'll divide both sides by cos 53 degrees. Even here, cos 53 degrees. So therefore t2 will be equal to, so if we get our calculator, we have 98 cos 45. The answer I find divided by cos 53. So the answer I'm getting is 115.14. If you want, you can say 5 newtons. But now I want us to understand one thing. Okay, we'll leave it that way. So we'll say t1 or is t2 is 115.14 newtons, and here is just 115.5. so if there is no difference actually. Okay, yeah. So I believe here I don't know what they did for them to find this answer 0.5, but it's supposed to be 0.14. Okay, from here now I have again to do now another question. If the question was just asking us to find t1 and t2, I would have ended there to say that is the answer. But the question is going further and ask us again. The question is again asking us to find m2. So to find m2, I'm going to use the forces now in y direction. So I'll say the summation of forces in y direction, we have got t1y pointing upward plus t2y also pointing upward minus this m2g pointing downward. So we replace this by 0 because the net force is 0. So this is going to be t1 sine theta plus t2 sine theta being equal or minus m2g. So if we want, we can shift this to the other side. So we have m2g being equal to, what is t1? I can plug in the values, or before I even plug in the values, I can write the formula plus t2 sine theta like that. So the m we don't know, but we know the g 9.8. What is t1? Okay, t1 is 98 sine the angle is 45 plus t2 is 115.14 sine 53. So let us see. I'll divide here by 9.8, even here by 9.8. So these two will cancel out, and then I'll remain with my m2 being equal. So I'm going to do direct for me to avoid the decimal places. So 98 sine 45 plus 115.14 sine 53. So the answer I'm getting 161.2513572. I divide it by 9.8. Okay, so the answer I'm getting, it is 16.45. If I round it off, my M2 will be equal to 16.5 kgs, and for sure here we have 16.5. So that's why I'm saying here they made a mistake. This was supposed to be 115.14 or 115.1, just like that. Yeah, so that is it for this type of static equilibrium. Okay,